Welcome to our lesson 1. In this lesson, I want us to look at halogen alkanes. The ones we commonly call alkyl halides. I call them halogen alkanes because they are believed to be derived from alkanes. And I would say that these are organic compounds in which one hydrogen atom, organic compounds in which one hydrogen atom is replaced, one hydrogen atom of the alkane is replaced by a halogen atom. Halogen atom, we normally denote them as X, where X is chlorine, bromine, or iodine. So, in the alkane, one hydrogen atom of the alkane is substituted by a halogen atom. For example, this is the alkane, but this is the halogen alkane. You have methane, but then one hydrogen atom is substituted, so you remain with the 3 of them, and the hydrogen atom is substituted by a halogen atom like chlorine. This is CH3, CH3, that is ethane, this is methane, whereas this is ethane. One of the hydrogen atom is substituted, and so remain with CH2, Br. This is the halogen alkane. We could have the cyclic one. This is cyclohexane. One of the hydrogen atoms substituted, and so we get a halogen alkane. Now, if these are halogen alkanes, it's important to look at their nomenclature. How are they named? Nomenclature of the halogen alkanes. These compounds are named. They are named as halogen alkanes. They are named as derivatives of alkanes. They are named as derivatives of alkanes, in which the halogen atom is considered as a branch, as a substituent, and named as chloro for chlorine, bromo for bromine, and iodo for iodine. Example. If we look at these first two here, this one is CH3Cl. The alkane with one carbon atom is called methane. And so the branch, this halogen atom, is going to be considered as a branch. And since it is chlorine, we shall name it as chloro, and then the alkyl. So this is chloromethane. This is chloromethane. When you look at the next example, these are two carbon atoms, and there is a bromine atom. Since two carbon atoms, that would be ethane, and this is bromo, ethane. This is bromo, ethane. When you look at this other example, which is cyclic, the alkane is cyclohexane. And so we will put the branch as iodo cyclohexane. However, the naming becomes interesting when the number of carbon atoms in the straight chains increases beyond 2. So I'm going to note something here. Not for halogen alkanes with more than 2 carbon atoms, with more than 2 carbon atoms, comma, position isomers, exist, and therefore the position of the halogen atoms must be specified. Must be specified. For example, if I have the molecular formula, or we can write the structure formula, CH3, CH2, CH2, bromine. It is possible that on the same carbon chain, the bromine atom could take another position of the carbon atoms. So C3, CH bromine, C3. These two compounds have the same number of carbon atoms, same number of bromine atoms, but on different carbon atoms, so they are position isomers. And during their naming, we would need to locate the position of the bromine atom. And in this case, when we are naming, since the halogen atom is the functional group, the naming should give it the lowest number possible. So I would begin from this carbon atom, and this one becomes carbon atom number 1, the nomenclature that we learned earlier. So this compound is going to be 1-bromopropane. That's the only difference now. That here, because there are no position isomers, we simply mention bromoethane, chloromethane. No position isomers. Iodocyclohexane, no position isomers. But when it comes to this, it's 1-bromopropane, meaning bromine is on position number 1 of the carbon atom. This one is 2-bromopropane. To distinguish it from that. So that will go on for carbon atom number 4, 5, and so on. But also, we would have those halogen alkanes with the benzene ring, what we call 4-aliphatic aromatic halogen alkanes. The benzene ring is a branch named as phenyl. That must be alphabetically arranged with the name of the halogen. An example, if we had in this case, the benzene ring is going to be considered as a branch, meaning the main carbon chain has only one carbon atom, and that is a methane now. Now, on this carbon atom, there is a halogen atom, and there is also a benzene ring. So we shall arrange the bromo and the phenyl. Phenyl is the branch given to benzene when it is not the main carbon chain. Is the name given to benzene when it is not the main carbon chain. So this one, the name will be bromo phenyl methane. Bromophenyl methane. Let's increase the number of the side chain on the benzene and we see what will that do. In this case, when numbering, bromine atom is supposed to get the lowest number possible. And since this is the main carbon chain, we shall number from the side. So this is carbon atom number 1, where this is carbon atom number 2. And that means on the first carbon atom, we have a bromo. I can change to another halogen atom, then put the iodo. On the first carbon atom, we have the iodine. On the second carbon atom, we have the phenyl. So this is 1 iodo. And on the second one, I have the phenyl. 2 phenyl. I have arranged these groups, phenyl and iodo, alphabetically. And then the main carbon chain has 2 carbon atoms, so it's an ethane. Phenyl, ethane. This is the nomenclature of halogen alkanes. We looked at those that are cyclic, those that are aliphatic, those that are aliphatic aromatic. And that is their nomenclature. I want now to look at the isomerism in halogen alkanes. Isomerism in halogen alkanes. Now, halogen alkanes exhibit, these have 2 types of structure isomerism. they can only exhibit two types of structure isomerism. Remember, there are three types of structure isomerism: chain isomerism, functional group isomerism, and then we also have what we call position isomerism. These ones only exhibit two, i.e. chain and position isomerism. Let's look at an example. Let's consider molecular formula C4H, this will be 9, and then bromine. So we would maybe I'll be asked to calculate the empirical formula, and then after calculating, we come up with this molecular formula, and then we are told to rate all the possible isomers of this compound. So normally the first isomer is a straight chain isomer. So we rate CH3, CH2, 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 bromine. This is a straight chain isomer. And what's the name? This is 1-bromobutane. But it is possible that we could change the position of the bromine atom from carbon atom number 1 to carbon atom number 2, and the structure would be CH3, CH2. This now will have the bromine atom CH3. And since this is position number 2, this is now 2-bromobutane. That's 2-bromobutane. Now, these two constitute what we call position isomers. These two constitute what we call position isomers, because the only difference is in the position of the functional group, but the carbon chain is the same in both cases. Now, it is possible to further get another isomer here by simply looking at the arrangement of the carbon atoms. Instead of 4 carbon atoms in a straight chain, we would put 3 and create a branch. So we would have CH3C. We create a branch of CH3, continue with CH3, and then put bromine there. 3 carbon atoms in a straight chain, the main carbon chain, and there is a branch. But still the same number of carbon atoms, same number of hydrogen atoms and bromine. This compound is now a propane. This is 2-bromo, but also on the second there is 2-methyl. And the main carbon chain is propane. Now, this is a chain isomer. Why a chain isomer? Because it differs from the other two in the arrangement of the carbon atoms within the carbon chain. So, these two are the main forms of chain of structure isomerism that we can exhibit in halogen alkanes. So what have we discussed so far in our introduction? We looked at what halogen alkanes are. We discussed the main nomenclature system of halogen alkanes, and then we have as well looked at the isomerism of the alkanes. In the next lesson, we shall be looking at how we prepare the alkanes, the halogen alkanes, the different methods, and the reactions of the halogen alkanes. Otherwise, this is our new topic. Don't miss the next lessons. Thank you for watching.